So in question 3, we're told that there's a line joining 2 points, which is the diameter of the circle C, and we have to find an equation for C. The first thing I'm going to do is draw myself a diagram just to help me visualise it a little bit more. It only takes a second and it could be really useful. So I'll just draw a rough axis, plot -1, 4, and 3, 6. And these are going to join together to make the diameter of a circle. So in order to find the equation of the circle, I need to think about the general equation for a circle, which is x minus a squared plus y minus b squared equals r squared. That's my general equation, where B is the centre of the circle and R is the radius. So first of all, I want to find the centre of the circle. Now that is the midpoint of the diameter. So I just need to find the midpoint of -1, 4 and 3, 6. Finding the midpoint is like finding the mean of the x-coordinates and the mean of the y-coordinates. So I'll write AB to represent the centre. So the mean of x is -1 plus 3 divided by 2. Those are the x-coordinates of the 2 points at the end of the diameter. And then y, we've got 4 plus 6 divided by 2. And that simplifies to 2 over 2, 10 over 2, which is 1 and 5. So that is the centre of the circle. Now I need to think about the radius. The radius is going to be half of the diameter. So I'll find the length of the diameter first, which is the distance between -1, 4 and 3, 6, and then I can divide that by 2. I could find the length between -1, 4 and the centre 1, 5. But I think it's a safe idea to go for the coordinates that you're given, just in case you'd made a little mistake when you found the centre. So to be on the safe side, I'll find the distance between these 2 points. So I'll write D for diameter, and that is the square root of 3 minus -1 squared plus 6 minus 4 squared. So what's happened there is I've found the distance between the x-coordinates there and squared it, and found the distance between the y-coordinates there and squared it, and this comes from Pythagoras. So I'll work that out. So that equals the square root of 4 squared plus 2 squared, which is the square root of 16 plus 4, 20. So R will be the square root of 20 divided by 2. But for the equation of a circle, I just need R squared. So R squared is 20 over 4, which is 5. Therefore, the equation of my circle is x minus, and I'll just check what my a is. So a is 1, so x minus 1 squared plus y minus 5 squared, that's my b coordinate, equals 5. That's my value for r squared, and that is your final answer, and it's the equation of the circle C. In question 6, we're shown a curve with equation y equals 5 plus 2x minus x squared, and the line with equation y equals 2. And we can see that they intersect at A and at B, and that's given to us in the question as well, that the curve and the line intersect at those points. So part A was to find the x-coordinates of A and B. So this is fairly straightforward. We just need to substitute in y equals 2 into the equation for the curve. So I've got 2 equals 5 plus 2x minus x squared. I'll rearrange this into a quadratic and equate it to 0 so that I can find the two values of x. So I'll move everything over to the left-hand side, so I get x squared minus 2x, and subtracting 5 minus 3 equals 0. And I can factorise that to get x minus 3 and x plus 1 equals 0. Just look back at the diagram to see which is which. So A is going to be the negative value, and B is going to be the positive value. So A, we'd say x equals minus 1, and at B, x equals 3. And part B, I need to find the area of R, which is this shaded region, and that goes between A and B. So I'm going to label on those x coordinates I've found just to make this really clear for me. So that is minus 1, and that is 3. And if I want to find the area of R, I've clearly got to do some integration between minus 1 and 3. So that's the first thing that I'll do. The function that I want to integrate is 5 plus 2x minus x squared, because that is the equation of the curve. The common mistake is to integrate the quadratic you found in part A. Make sure you don't do that. Think about what you're doing and find the area under this curve here. So you need to use this formula. So we're going to integrate that. And we already said that's between minus 1 and 3. And it's 5 plus 2x minus x squared dx. So as I'm integrating with respect to x, I will be changing the x terms. And this integrates to 5x plus x squared, or 2x squared over 2, minus x cubed over 3. So the rule is increase the power by 1 and divide by the new power. Now because I've got limits in here, I don't need to add a constant of integration, but I need to write it like this. I need to keep those limits in. So I put in the square brackets, and now I put the limits at the end. And then I will evaluate this function for x equals 3 and x equals -1. So I've got 5 times 3, 15, plus 9, minus 27 divided by 3, which is 9. Subtract. We always subtract the two values. 5 times -1, so -5. -1 squared, so +1. And then minus x cubed over a third, so that's minus times -1 cubed, which is negative as well, so it's positive, plus 1 over 3. If I do all that working out, I end up getting 18 and 2/3. Now I'm going to think about what does this area actually represent. And if I look back at the diagram, it is not yet the area R, because this area is everything underneath the curve between -1 and 3. So it is all of this. So I've got to get rid of this extra bit here. I need to subtract this from the area in order for me to find out what R is. But this shape is just a rectangle. So I can easily work out the area of that. The distance along here, its length is 3, between 3 and -1, so that's 4. And its height, I can see because of that line y equals 2, is 2. So the area of that rectangle is 2 times 4, which is 8. And then I will need to subtract that from my value that I've got below. So my final area is 18 and 2/3 take away 8, which is 10 and 2/3. There you go.